Leaving cert higher level, coordinate geometry of the circle, extra examples. Equation of a circle, centre 0, 0 and a radius r. A circle is a set of points, a locus, each of which is equidistant from a fixed point called a centre. The distance from the centre to any point on the circle is called a radius. The diagram shows a circle with centre 0, 0, radius r, and x, y as any point on the circle. The distance between 0, 0, the centre, and x, y equals to the radius r. So subbing these 2 points into the distance formula, we get the square root of x minus 0 squared plus y minus 0 squared is equal to r. So r being the radius, being the distance from the centre to the point. This simplifies to the square root of x squared plus y squared is equal to r. And the square root comes over the equal sign, becomes squared. So we get x squared plus y squared is equal to r squared. So this is the equation of a circle with a centre 0, 0. So hence, x squared plus y squared equal to r squared is said to be the equation of the circle. So equation of a circle with a centre 0, 0 and a radius r is x squared plus y squared equals r squared. Two quantities are needed to find the equation of a circle, the centre and the radius. If the centre is 0, 0, the equation of the circle will be in the form of x squared plus y squared is equal to r squared. Find the equation of the circle K with centre 0, 0, which has a radius of root 13. The centre is 0, 0, therefore K is of the form of x squared plus y squared equals r squared. Substitute r equals root 13 into this equation, so we get x squared plus y squared equals root 13 squared. X squared plus y squared is equal to 13 because the root and the squared cancel. Thus the equation of the circle K is x squared plus y squared equals 13. Find the equation of the circle C whose centre is 0, 0 and which contains the point 4, minus 1. Method 1. Centre 0, 0, therefore C, the circle, is in the form of x squared plus y squared equals r squared. So we have x squared plus y squared is equal to r squared. We're going to swap the x for 4 and the y for minus 1. So we have 4 squared plus bracket minus 1 squared equals r squared. That gives us 16 plus 1 equals r squared, so r squared is equal to 17. Thus, the equation of the circle C is x squared plus y squared is equal to 17. Method 2. The radius is the distance from the centre 0, 0 to the point 4, minus 1. So we're going to label them x1, y1, x2, y2. We're going to use the distance formula and substitute into the distance formula. So we get the square root of 4 minus 0 to be squared plus minus 1 minus 0 to be squared, which gives us the square root of 16 plus 1, which is the square root of 17. Thus, the equation of the circle C is x squared plus y squared is equal to 17. Find the radius of each of the following circles. So we have x squared plus y squared is equal to 8. So if we compare each to x squared plus y squared is equal to r squared, we have x squared plus y squared is equal to 8, and x squared plus y squared is equal to r squared. So these must be equal. So we have r squared is equal to 8. So r is equal to the square root of 8, which is 2 root 2. Then we have 4x squared plus 4y squared is equal to 25. So if we want this to look similar to x squared plus y squared equals r squared, we have to divide across by 4. So dividing by 4, we get x squared plus y squared equals 25 over 4. So 25 over 4 is going to be equal to r squared. And r squared is equal to 25 over 4, so r is equal to the square root of 25 over 4, which gives us 5 over 2. So the radius is 5 over 2. The diagram shows a tangent 3x plus y minus 10 is equal to 0 to the circle K. So here we have a circle called K, and here we have a tangent which has the equation 3x plus y minus 10 is equal to 0. So a tangent is a line that touches a circle at only one point, and it is perpendicular to the radius. Find the equation of K. So we need the equation of the circle. So As the centre of the circle K is 0, 0, its equation is in the form of x squared plus y squared is equal to r squared. So we need to find the value of r. The radius r is equal to the perpendicular distance from the centre 0, 0 to the line 3x plus y minus 10 is equal to 0. We're going to use the formula for the perpendicular distance from a point to a line. So this is our formula for the perpendicular distance, which will give us the distance of the radius. So this is the formula for perpendicular distance from a point to a line. So that point will be 0, 0, and that line will be 3x plus y minus 10 is equal to 0. So we label the point as x1, y1. We label our line as a, b, c, and then we substitute into the formula. So r stands for the radius is equal to the modulus of 3 times 0 plus 1 times 0 minus 10, all divided by the square root of 3 squared plus 1 squared. So 3 times 0 cancels, and 1 times 0 cancels. So we're left with minus 10 on top, so the modulus symbol as well around the minus 10. 3 squared is 9, 1 squared is 1, 9 plus 1 is 10, so that's over root 10. So the modulus of minus 10 is 10, so we just take the positive value. So we have 10 over root 10, which just gives us root 10. So the radius is root 10. So r squared is equal to root 10 to be squared, which is 10. Thus, the equation of the circle K is x squared plus y squared is equal to 10. General equation of a circle, centre h, k and radius r. On the right is a circle with centre h, k, radius r, and xy is any point on the circle. So here we have a circle, centre is hk, so it's not 0, 0, it's not the origin, and x, y is any point on the circle. The distance between h, k and x, y equals the radius r. So using the distance formula and using these 2 points, labeling them x1, y1, x2, y2, we have the square root of x minus h to be squared plus y minus k to be squared is equal to r standing for the radius. Squaring both sides to get rid of the root on the left gives us x minus h to be squared plus y minus k to be squared is equal to r squared. Hence, x minus h to be squared plus y minus k to be squared is equal to r squared is said to be the equation of the circle. So the equation of a circle with centre h, k and radius r is x minus h to be squared plus y minus k to be squared is equal to r squared. So this is the equation of a circle for a centre that's not 0, 0. So the centre is h, k, the radius is r, and we use the formula x minus h to be squared plus y minus k to be squared is equal to r squared. Note, if h, k is equal to 0, the equation x minus h to be squared plus y minus k to be squared is equal to r squared is reduced to x squared plus y squared is equal to r squared. Basically, the h and the k become 0, and you end up with this. Find the centre and radius of the circle x minus 2 to be squared plus y plus 5 to be squared is equal to 9. So we have x minus 2 to be squared plus y plus 5 to be squared is equal to 9. We compare it exactly to our general equation, which is x minus h to be squared plus y minus k to be squared is equal to r squared. So we see that h is equal to 2, so h is equal to 2. So the x value of our centre is 2. And then k is equal to, it's not exactly equal to 5 because we have a plus here. And we know that plus 5 is the same as minus 5. So minus k is equal to minus 5. So k is actually equal to minus 5. So minus 5 is our y value. And then r squared is equal to 9. So r is equal to the square root of 9, which is 3. If r squared is equal to 9, r is equal to the square root of 9, which is 3. So the radius is equal to 3. Now, a much quicker way of doing this is literally just saying, well, if this is minus 2, we'll change the sign to get positive 2. If this is positive 5, change the signs to get minus 5. And if this is 9, square root it to get 3. So that's what I would do instead of writing all of this out. Find the equation of a circle with a centre 1 minus 4 and a radius root 13. So the centre is 1 comma minus 4, the radius is root 13. So h is equal to 1, k is equal to minus 4, and r is equal to the square root of 13. The equation of the circle is x minus h to be squared plus y minus k to be squared is equal to r squared. So we swap the h for 1, the k we swap for minus 4, but we end up with minus minus 4, so that gives us plus 4. And the r we swap for root 13. So we have x minus 1 to be squared plus y plus 4 to be squared is equal to the square root of 13 squared, so the square root and the squared cancel, leaving us with 13. So again, a quicker way to do this would be to say, well, if 1 is our x value in our centre, then we end up with minus 1 inside the brackets. We just change the signs. If minus 4 is our y value for our centre, then we end up with plus 4 inside the brackets with the y. We just change the signs. And if the radius is the square root of 13, then we just get rid of the root and we're left with 13. Find the equation of the circle that has the line segment from A, minus 4, 1 to B, 2, 3 as a diameter. So we need to find the centre and the radius. This is usually how we start these questions, find the centre and the radius. The diagram on the right illustrates the situation. So here's our x-axis, here's our y-axis. We have the point A, minus 4, 1. So there's minus 4, 1. And we have the point B, 3, 2. And we know that these are the endpoints of the diameter of our circle. So our circle will go around these. So we want to find the centre of the circle. Well, that's basically the midpoint of the diameter. So we use our midpoint formula, bracket x1 plus x2 over 2, comma y1 plus y2 over 2. So the centre is the midpoint of the line AB, or the diameter. So the centre is equal to minus 4 plus 2 over 2, comma 1 plus 3 over 2, which gives us minus 1, 2. So the centre is minus 1, 2. The radius is the distance from the centre, minus 1, 2, to either minus 4, 1 or 2, 3. You can choose whichever you want. So let's go with 2, 3. So we're going to get the distance from the centre, minus 1, 2, to the point 2, 3. We're going to use our distance formula for that. So we label the points x1, y1, x2, y2. And then we sub into our formula. So r, the radius, is equal to the square root of 2 plus 1 to be squared, plus 3 minus 2 to be squared, which gives us root 10. So our centre is minus 1, 2. So the h is minus 1, the k is 2, and the r is root 10. So the equation, the general equation, is x minus h to be squared plus y minus k to be squared is equal to r squared. So swapping the h for minus 1, so we get minus minus 1, which is plus 1. Swapping the k for 2, so we get y minus k. And then swapping the r for root 10, so we get root 10 to be squared. So that gives us x plus 1 to be squared plus y minus 2 to be squared is equal to 10. Because the root and the squared will cancel. So again, a quicker way would be, well, if I know that this is the centre, well, if the x value is minus 1, then I put plus 1 into the brackets with the x. And if the y value of the centre is positive 2, then I put minus 2 into the brackets with the y. And if the radius is root 10, I just take off the root. And I'm left at equals 10. General equation of a circle. The general equation of a circle is written as x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. When the equation of a circle is given in this form, we use the following method to find its centre and radius. Number 1. Make sure every term is on the left-hand side and the coefficients of x squared and y squared are equal to 1. So basically that you've got x squared plus y squared at the front, so you don't have 2x squared plus 2y squared or 4x squared plus 4y squared and so on. Although if you did, for example, have 2x squared plus 2y squared, etc., you would just divide everything by 2 so that you end up with x squared plus y squared. The centre is minus g comma minus f. So if we have 2gx and 2fy, then the centre is minus g minus f. So what that means is we halve the coefficient of x, whatever stuck onto the x, we halve it, and we change the sign. So minus half the coefficient of x, and we do the same with the y. So whatever stuck onto the y, we change the sign and we halve it. So we get half minus half the coefficient of y. And then the radius is the square root of g squared plus f squared minus c, provided g squared plus f squared minus c is greater than 0, because you can't have a negative root. So whatever you get for the centre, the x value, square it, add on the y value, square it, and then minus c. So whatever this happens to be, you minus it. So if this happens to be 6, you put minus 6 under your square root. If this happens to be minus 2, you put minus minus 2, which is plus 2, underneath the square root. Note, the equation is of the second degree, highest power is 2. The coefficients of x squared and y squared are equal, and there is no xy term. Find the centre and the radius of each of the following circles. X squared plus y squared minus 4x plus 2y minus 11 is equal to 0. So we take the coefficient of x minus 4, we divide by 2 and change the sign. So minus 4 divided by 2 and changing the sign gives us positive 2. We do the same with the coefficient of y. 2 divided by 2 and change the sign gives us minus 1. And then we label the constant at the end as c. We label the x value of the centre as g and the y value of the centre as minus 1. Then to get the radius, we put it into this formula, the square root of g squared plus f squared minus c. So we get the square root of 2 squared plus minus 1 squared minus minus 11, which gives us plus 11. And that ends up giving us 4. So the radius is 4. Find the centre and the radius of this circle, x squared plus y squared minus 8y plus 3 is equal to 0. So notice that we have no x term here, so we're going to put in 0x. So we take the coefficient of x, we halve it and change the sign, but you're still going to be left at 0, so our x value is 0 for our centre. We take the coefficient of y, which is minus 8, we halve it, change the sign to get 4. So the y value of our centre will be 4. So we label that G and F. Then we take the constant at the end plus 3, we label it as C. And then to get the radius, we substitute into this formula, the square root of G squared plus F squared minus C. So get the square root of 0 squared plus 4 squared minus 3, which gives us the square root of 13. So the centre is 0, 4, the radius is 13, the square root of 13. The equation of a circle with a radius 5 is x squared plus y squared minus 6x plus 4ky plus 20 is equal to 0, where k is an element of the integer set. So k is a positive or negative whole number. Part 1. Find the centre of the circle and the radius length in terms of k. That just means keep k in the answer. So we're going to write out the equation again. So x squared plus y squared minus 6x plus 4ky plus 20 is equal to 0. We take the coefficient of x, which is minus 6, we halve it and change the sign to get 3. So the x value of our centre is 3. We take the coefficient of y, which is 4k, we halve it and change the sign to get minus 2k. So the y value of our centre is minus 2k. Then we label the x value, which is 3, as g, and the y value, which is minus 2k, as f. And we label the constant plus 20 as c. So we have g, f and c. Then we substitute into our radius formula, which is the square root of g squared plus f squared minus c. So we get the square root of 3 squared plus minus 2k to be squared minus 20. 3 squared is 9, and 9 minus 20 is minus 11. And minus 2k multiplied by minus 2k is positive 4k squared. So the radius is the square root of 4k squared minus 11. So the centre is 3 minus 2k, and the radius length is the square root of 4k squared minus 11. And these are in terms of k, that means k is in them. Part 2, find the values, plural, of k. So what was given in the question is that the radius is equal to 5 units. So we just worked out this to be a expression for the radius. So we have the square root of 4k squared minus 11, and we let it equal to 5, because that is what the radius is that was given in the question. And next we solve for k. So the root comes over and becomes squared. So 5 squared is 25. So 4k squared minus 11 equals 25. The minus 11 comes over, becomes plus 11. 25 plus 11 is 36. We divide both sides by k. We divide both sides by 4. 36 divided by 4 is 9. So if k squared equals 9, so k is equal to the square root of 9, which is plus or minus 3. So the two possible values of k is plus or minus 3.